Great.
with no coordination. We've all ended up not only in black t-shirts, but I'm technically in a Science Actually t-shirt.
Oh, wow.
Yeah.
Yay!
I want to know what threshold of interviews I need to hit before I get a Science Actually t-shirt.
You are in. That's it. I'll have them off to you today. Not even kidding. I'll ask for an address later and I'll send them off.
Benjamin actually made an incredible design the previous time that we had you on, and hopefully that's the design that Benjamin chooses to share with you.
Okay.
But before we get into everything, I know the last time we dove into 10 minutes of fantastic discussion before I even introduced you to all of our listeners and watchers. So off the bat, today we are very fortunate on this week's episode of Science Actually Presents the Nerd and the Scientist to have Dimos joining us again, our first ever guest and our first ever return guest.
Pleasure.
Wild.
This is crazy.
Yeah. Oh, thank you for coming back.
That's a joy. It's a joy to talk about what's going on in the rocket launch world, especially on the New Glenn side, because we're very close to having a rocket launch. I have been reading up with and talking to my friends who are presently at Blue Origin about the schedule, and they're working hard to make mid-December an upcoming launch date for the New Glenn launch system with an interesting payload. Officially, Blue Ring is going to be taken up into space, and it'll serve as a utility vehicle for moving satellites from one Earth orbit to a different Earth orbit. Essentially, like a big moving van, if you will, with satellites. But we'll introduce you guys first a little bit to the New Glenn rocket. I have a model here. These were made at work, essentially as a way for us to show off to our friends and family.
It's amazing.
New Glenn on it. So
I was worried you wouldn't have another fantastic model after the new Shepard model that you had last time, but this is even better.
This was an interesting model. It is somewhat less detailed, but let's go through some of the important details. Back here, if you look carefully, you'll see 1, 2, 3, 4, 5, 6, 7 BE4 engines. And also what you see deployed, and there's no way for me to undeploy these unlike the other model, but the landing feet, can't really call them landing legs because dimensionally they're but very much smaller than the New Glenn rocket itself. We also see some aerodynamic strakes here at the bottom. I'll point them out to you. These, as well as the fins here. And so when this rocket comes back from its trip to space, it needs some aerodynamic guidance, and this is part of that. As you might remember with Falcon Heavy or just regular Falcon 9, the grid system is used as an aerodynamic control surface. Right. In this case, we have fins, more like a model rocket that you might fly from Estes. And so that is an aspect of this that makes it a little bit more traditional looking. Over here, we have little doors that open up that cover the top of the landing leg.
Oh,
and
sweet.
Those
so
doors,
the landing legs are contained inside.
So they fold up and are not in the way of any of the enormous, massive amounts of thrust and fire that are coming out of the back of this thing. Also, upon re-entry, these legs need to be protected because anything and everything on this rocket gets ridiculously hot on re-entry. One of the things that I'm going to do is, we've seen the whole rocket, but I'm going to crack open this rocket to reveal the second stage, which has just cracked here. So here we go. And you see two BE3U engines. The first engine.
That is so cool.
The BE4 engines. And the BE3U, there's two of them on this. And
are those the same engines as from the first stage?
So, no, actually, this is a completely different design program, and I had the pleasure of being the technical lead for the engine controller for this engine product. This this engine is designed based on the original New Shepard rocket, the one that has made lots of news carrying tourists to a short
Got
ballistic
it. Got it.
trajectory that gives everyone about 5 minutes of hang time in zero gravity and then
The
gets
new
back to
Shepard
Earth.
has one engine, and those are
And
two of the same engine.
yeah, and so these are not completely the same. They use a different combustion. That one's a tap off. It's a very inefficient engine compared to this engine, but they're both hydrogen and liquid oxygen based engines.
Hmm.
But this one is a staged combustion engine, so it keeps all of its fuel and uses all of its fuel for thrust. In the case of the tap off engines, much more basic design.
And just for the folks who are listening and not watching, so what Demos has done is basically taken this, maybe nearly a meter long model of the entire New Glenn and just cracked off the top to pull the second stage out. And the second stage is, I guess, comparable in size to the New Shepard, maybe a little bit bigger.
Yes, in fact, actually, I would say the second stage is twice as big as the New Shepard. I've now smacked it again, and now the payload fairing has come off. The new Shepard can fit inside the payload fairing.
Wow.
No.
Yes, it's true.
I love that.
Yeah, we're talking about New Shepard is about 40 feet tall, so you can put New Shepard inside the payload fairing quite easily. And
Seriously.
the payload fairing is actually quite large in diameter, 7 meters. It's
70.
not
Yeah.
quite as big as Starship's, which is 9 meters in diameter, but 7 meters, 23 feet, still reasonable size for pretty serious payloads. Though I will say that the published payload capacity of Starship is quite amazing, and I think they say it can handle somewhere up to 330,000 pounds of payload on Starship.
Wow.
New Shepard has, or New Glenn has not published its payload, but theoretically, a dry payload of New Shepard could be a payload. So that's about all the details I can offer there, unfortunately.
No, that's brilliant. It's like, yo, dog, I heard you like rockets, so I built you a rocket that has a second rocket inside which it can carry another rocket. Like, wild.
Well, I mean, in some ways, think about it though. It comprises a third stage, right? And so once you achieve translunar injection, then you're going to use that to get you to the moon. But if you need to go to Mars, you're going to need another rocket to enter Mars orbit and then
Right.
leave Mars orbit. So the hope would be that you would go to a larger, maybe a geo orbit of some sort. And that's really for the orbital mechanics guys or gals to calculate. And so what we're talking about here is essentially about 100,000 pounds of weight that is going to be pushed. And interestingly, the amount of force with payload and the weight of this second stage, the amount of force generated by these two engines is about the same as the weight of this entire item. But you're in space, so you can you just have slower acceleration. In the case of like Starship, it's about 3 times that, so you can accelerate quite fast. And I think a lot of that has to do with the inclination for Mars-based missions, which seems to be the most the biggest preoccupation
Yeah.
for the Starship design strategy.
In
Fully,
terms of comparison, oh, sorry, go on.
sorry,
Go
fully
ahead.
assembled. Is New Glenn going to be bigger than Starship?
Actually, Starship fully loaded is quoted at being 122 meters long. Fully loaded and full length, at least with the present payload fairing size,
Sure.
it's not going to exceed 100 meters for New Glenn. So Starship is bigger. Starship is bigger by about 20% than New Glenn at this point. However, that doesn't necessarily have to be there. There's no real limit to the payload fairing size. Really, all it does is affects the dynamics that can be adjusted on the rocket engines. as you know, all rocket engines have gimbals that control where they're pointed. We call this thrust vector control, TVC.
Mhm.
And these gimbals have a hydraulic system. And partly hydraulics are for extreme force. You can control a lot of force. And when you're talking about nearly 4 million pounds of force, you're not going to be able to do that with electrical positioners as easily as you will with hydraulics. So,
Mhm.
a large battery, high voltage battery, pumps, and the whole hydraulic system is in place on first and second stage for thrust vector correction. On smaller rockets, you can do it electrically. And a good example of that, for example, would be Rocket Lab's Electron, where all of the functions are handled electrically, including pumping of the fuel through the rocket engine.
So the thing that I'm wondering is, I've heard that originally the second stage wasn't planned to be reusable, and then it was kind of updated, right? Like it seems like the second stage is really quite similar to New Shepard, just like a souped up version of it, and that was is reusable. So what's the story there?
So there was a talk of Project Jarvis, which was the plan, and I remember Project Jarvis being talked about seriously when I was there. I think the plans for that have at this point been shelved. So unfortunately, New Glenn is not a fully reusable system. And I think a lot of that was to focus on mass to orbit, total
Mm-hmm.
mass to geo, because you can have 1/10 of the mass. You can lose a big penalty. There's a big penalty in going from low Earth orbit to going to geostationary orbit.
Sure.
And so having enough fuel to make that transit makes it hard. So if you can drop weight on the rocket, that's generally a good thing. Right now, what I've, at least on the research that I've done on Starship, it shows that they're using liquid methane or liquid natural gas for the fuel on both second and first stage. Now, liquid methane does have a higher energy density than hydrogen. It
Mm-hmm.
certainly does. I mean, liquid hydrogen has good energy density, but liquid methane has 4 times as many things to burn, including twice as much hydrogen and a little carbon, right? CH4 versus H2.
Sure.
So you're going to get more time in space. You're going to get more thrust, and you're going to be able to lift more weight, and that's a big benefit of using that.
It sounds like it kind of ties back into what we spoke about in our previous episode. For folks who haven't listened to it or watched it yet, go do that now. Pause, stop whatever you're doing, and go listen to our first episode. But you spoke about this idea of kind of intentional inefficiency for the purpose of testing these techniques that would rely on taking lunar ice and mining the hydrogen from that in order to refuel. So I guess this is kind of in a similar vein.
Yeah, and frankly, that's actually more beneficial for the New Glenn design because by going to the lunar surface, you're not going to get methane on the lunar surface, but you will be able to get ice water, and eventually convert that into liquid oxygen and liquid hydrogen. And so, in that regards, it is beneficial to have a hydrolox type engine that
Fair enough.
could use lunar fuel. And there's a lot of effort right now being spent with DARPA on developing lunar infrastructure. As we had mentioned last time in our meeting, there's companies like Northrop Grumman who are working on lunar railway, essentially melting the lunar regolith and making rail out of it so you can put a train on the moon. And it's given the logistics challenges, a lot of what we're going to be doing on the moon is moving material in order to build a habitat, straightening material out, and then making a transport setup between various places. The lunar dust is a big deal. It's extremely difficult to have equipment and machines working around it. And just the concept of getting in and out of your lunar vehicle when you're there and tracking in all of that dust and then having to deal with that is a big part of the design of these
Yeah,
habitats.
I
And
remember lots
yeah,
of articles and there's lots of pictures of it too, of the Apollo astronauts. They go out, everything's beautiful, and they're nice white outfits, and they come back in, everything's covered in soot. No matter what they do, they just it gets into everything. It's incredibly fine and rough, and it's everywhere.
Yes, absolutely.
It's dirt and it's dirty. You don't get that impression looking at the moon. It's just incredibly dirty.
Pristine from a distance, yeah.
As far as some of the background of New Glenn and what happened with the story behind the development of this, as you know, Blue Origin has been around since 2004. It's now a 20-year-old company, and really a brainchild of Jeff Bezos, an avid rocket guy. And in 2012, there was some talk about doing a heavy lift rocket, which was and making it completely self-landing. So by 2012, there had already been a flight of New Shepard, and also there had been a failure with New Shepard. So
Mhm.
there is some experience under the belt of the New Glenn team, as you know, as an offshoot of the New Shepard team, of the New Shepard designers. And at this point, the company was also still quite small. It was only about 300 people in the company. So you can just imagine the magnitude of work that they'd been doing at that point. So they started development in about 2013, and then a formal announcement of the program was in 2016. I had joined Blue Origin at 2016, so I was around that time when there was definitely a lot of work going on, and by then it was now 700 people. I was actually the number 700 to be hired, and the work happening at that point, a lot of it was detail work on not only developing the rocket and coming up with things to do to deal with how to get a large rocket back to the Earth without it burning up on reentry. There was also a number of discussions regarding something like designing the launch pad. I don't know if I had mentioned it later previously, but when a rocket of this amount of power takes off, the exhaust velocity of all seven BE4 engines running is 7 to 9,000 miles per hour. As you know, that's much faster than the speed of sound. And part of that is we're trying to essentially create that force. So the specific impulse is actually half of that, but the exhaust velocity is coming out quite fast, and in an air breathing engine, specific impulse would be the same as exhaust velocity. So with all of that high speed uh, material coming out, the shock wave created by the exhaust trench that's well underground and coming out the other side would potentially hit the top of the rocket as the rocket is taking off and knock the payload off. So just to give you an idea of the forces involved in just the noises that this rocket makes taking off. So it's pretty scary.
I don't think we spoke about that last time. That is pretty wild.
Incredibly, like, insanely powerful. We no New Glenn has launched before, right? So
That's right.
this is
So
quite an ambitious first mission. I mean, launching to space with a payload, launching a satellite, landing on a ship. Especially, this is the biggest thing to land on a ship.
it is. It is.
It,
So
it's
yeah, because Starship hasn't done that.
no.
Now, Starship has done some pretty amazing things, historic things, and
Oh
and
yeah, yeah.
and I think everyone celebrates Starship for that.
Mhm.
But landing on a ship's going to be amazing, and the ship is about 1,000 kilometers or 600 miles downrange, so it's going to be a long trip back, whether you've caught the ship or not. But but hopefully, New Glenn will land, and when it does, um, when it actually lands on the ship, one of the interesting things it does is there's pyrotechnic devices under each leg that fire off like a dynamite charge of an anchor into a perforated surface on the deck of the ship. So it essentially, when touchdown occurs, there's a little pressure sensors under each foot, and as
To
soon as the
latch
pressure
in.
sensor makes positive contact, it latches in, and then the
It
next one
harpoons the ship.
positive and latching in. All of this is happening while reaction control systems at the top of the rocket are trying to stabilize the top side. So so it's coming in, it's trying to be all stable and everything, and then it finally touches down, and it's essentially deploying explosive charges to try to drive an anchor into from every leg into every part of the ship's core. And at that point, then they can turn off all the systems, allow the rocket to cool down, and it's now attached to the ship.
I like it's clearly Blue Origin is learning from the previous efforts that were made at SpaceX, because I feel like the first half a dozen or so attempts to land at sea, um, what was the term they used, often resulted in rapid, spontaneous, unscheduled disassembly.
Right.
Yes, yes, and they have named this this booster, so you think we have a chance. And so I don't know where it's printed on the booster, but that's the name of the booster.
I think we have a
Because
chance.
it's anyone's guess at this point. There's two of these, and they're going to launch one of them as a demonstration mission. Blue Ring is or Blue Ring is going to be an interesting payload, because once it unfurls, it will be a demonstration mission to, one, show new Glenn's capabilities, show the second stage capabilities, show the proper behavior of the payload fairing, and it's amazing how big these are. They just
Yeah.
say, again, a good solid, uh, I would say about 150 feet of payload fairing. So it's just massive. And so you've got all of this space. You have to show that it all comes apart. You've got your frangibolts, you've got your pyrotechnic igniters to release one piece from another piece, and then deploy a payload and safely do that, and then let the payload, which is also built by Blue Origin, go into space and then turn into a parking spot for other satellites. So it's a pretty amazing mission in its own right.
That's insanity. That's huge. It's just huge. The scale of it all.
And the scale of the
For
project
those who
is quite
can't see,
amazing.
even his model is, even it's a small model, it's freaking huge. And that's the toy.
Yeah, it's the toy. We tried so hard, and I think it's going to happen, but we tried 4 years ago to get a Lego version of this. And we were just short of the 10,000 votes needed for Lego to issue a model of this. But I think that's going to happen in December. It won't be here in time for Hanukkah, Christmas season, but we'll be there at some point.
I will definitely get one of those.
I'm buying it. I'm buying it. I don't need to eat. I'll just buy that instead.
So, as far as other exciting technologies, I will say that Blue Ring is pretty cool. I don't know if you've heard of Orbital Reef or Blue Ring, but it's all part of this infrastructure system that Blue Origin has set up for space. Blue Ring is going to be the semi truck of space, and there's a Wall Street Journal article about that, which I cheaped out and didn't buy the subscription. But but I know a little bit about Blue Ring because I got to work on a little bit of the power system concept for Blue Ring. And so Blue Ring is really cool because it sounds very science fiction-y. And part of that
It
is
does.
because it uses an extremely large ion drive. And, if you're talking about like Star Trek or even Star Wars, you hear that term thrown around loosely. But it is actually a way of moving a payload at an extremely high efficiency. The ion drive literally creates a large electric field and accelerates a gas like xenon or some other reaction gas, and uses it as a very gentle thrust. And when we say gentle, you would probably barely feel it on the back of your hand if it was operating at full power. We're talking about maybe hundreds of tens of grams of force for regular ion thrusters, and maybe a few kilograms of force for the most powerful ones. Now in space, that's a big deal. You can do a lot with that over time. because you
Yeah,
simply push ever so gently against something and you can pick up amazing speeds.
yeah. It just keeps adding and adding and adding.
Exactly. And over time, you're hitting amazing speeds. You, along with using gravitational dynamics and regular thrusters, you can do some pretty amazing things with ion drive. But the other cool thing is with ion drive, you can use solar power. So you've got an energy source that helps with the major component of the drive, which is the acceleration. And so that solar power is one of these ways of giving Blue Ring the ability to go between orbits and to basically transit from low Earth to high Earth. So, in other words, Blue Ring could take say, 8 satellites to high Earth orbit, to geostationary, drop them off, make sure they're all fed and happy, let them loose, and then change its orbit, go back to low Earth orbit,
Wow.
and pick up another set of satellites. Now, it
Blue
would
Ring can pick
probably
up
take
several
a
at a
month.
time.
Oh, yeah, it could take about 8 at a time. Now, in the
This
world
is
of
an
nano
ambitious,
satellites, it's a small.
ambitious mission.
But the expectation would be that there would be several Blue Rings operating. There would be more than just one. And so Blue Ring would become a network to its own right, but a very interesting one in that a it's unlike the space station. Like the space station, for example, is reliant on other vehicles to get it into different orbits or even to move it out of the way of space junk.
Mhm.
There's actually a very interesting Falcon or a Dragon um, event that occurred yesterday, where a Dragon lifter was used to reposition the space station. Normally, it's done with Soyuz, and so now we have a U.S.-made approach for changing the altitude of the space station.
I
So
think that's
that's pretty
also a
exciting.
test in itself because SpaceX is going to be pushing the ISS back down at the end of its
Exactly.
life. So
Yeah.
I guess
And
now they
so
know they can
there's
use
a
it.
lot of benefits that come from this. There's still a little bit of service life left, but yes, they're going to be
Yeah,
strapping a Dragon onto it and giving it its final heave ho into the ocean. Or hopefully not in, hopefully it'll burn up on reentry, but chances are not all of it will.
Sure. Yeah.
Yeah,
terrible. Sad.
it is sad. But to replace it, Orbital Reef, which has its own tagline, your address in orbit. Orbital Reef will be a new business park, a office complex that will allow you to do science experiments, do manufacturing processes, maybe have a tourism section, all in space. And so Orbital Reef will be a next step for realizing habitat in orbit. So it won't be going to the moon, but it will give you the ability to go to a midpoint and maybe get yourself acclimated for your next step, which would be to go to the moon.
That's so cool. It's like a PO box in space, or like a Leo box.
A Leo box. Yes. Well done. So we have Blue Origin, Sierra Space, Boeing, actually, Redwire, and AWS, even Arizona State University. So there's public, private, and as well as university interest into making Orbital Reef a success. That's going to be a while, but it does take the heavy lift capability of either Blue Origin or Starship to
Mhm.
get those items into space. And so there we
Wow.
are. We've got all of these amazing platforms, as well as what hopefully we will see in mid December being a tool to get us there. So now, really, I've got a few more details written down, but I'm wondering what other questions do you have?
So, big question. Given that Blue Origin hasn't, they've tested the engines and stuff, which I've seen, but they haven't tested the booster or the rocket itself yet. This is going to be the uh, for other rocket companies and for NASA and ESA whenever they're developing a new rocket. They test the stage, they launch a small thing, they launch a bigger thing, and they work their way up. It seems like Blue Origin is going from a few tests to full thing. Here we go. Ready, everything's ready to go. How do they get to that kind of a confidence in which this is a very big, expensive test? It's the full deal.
I think there's plenty of confidence to be had when you have well defined models and that you've flown a lot. And so Blue Origin is scaling the models that they've created for New Shepard in a way that they can observe the proper behavior in space. We do something in the space world and in aerospace in general called hardware in the loop testing. And what that is you create a very realistic model of the rocket, which isn't that hard to do. Uh, for example, if you've ever taken a broom handle and put your finger under the handle, you find that the longer the broom handle and even the heavier the broom handle, the easier it is to balance it on a single finger. And that's because you just make tiny little movements at the bottom and you can keep that broom handle stable and pointed upward. And in the reality, as long as the rocket doesn't explode, uh, creating creating thrust, as long as the engines hold together, and as long as you've got a good control system that can handle things like sloshing inside the tank, because the fuel is sloshing around in there. And so if you have a lot of movements or a lot of turbulence, that can be an issue. So the models take into account the slosh. The models take into account the potential for maybe losing an engine even while on en route. All of these rockets have the ability to handle engine out liftoff. You need that. Now, it could very well be that you have to then implement a reentry, or if possible, if the engine out can be separated, you may have enough fuel to get you at least over the Atlantic, and then you can dump or even call off the mission, which certainly would be a destructive. We have something called range safety, where
Mhm.
if you tilt, go off axis, start leaving your cone of safety, then at that point, a range safety officer, along with the launch crew and the ground systems engineers, will then decide to trigger a controlled destruction of the vehicle. So those are issues that we deal with. But to get back to your point, how does Blue Origin have the confidence to think that they can fly this thing? Well, hot fire is one of those ways. There was recently a hot fire of the first stage. So I'm sorry, the second stage. So the second stage was hot fired for about 15 seconds. Both engines were run. It was fueled up. The repressurization system was tested. In this case, helium is used to repressurize the second stage. And the first stage originally was going to use a repressurization system based on reheating the internal liquid of the liquid, the LNG, liquefied natural
Hmm.
gas. However, I think for simplicity's sake, they're going to stick with helium for this first run, because developing the other technologies just pretty heavy lift. Their gaseous repressurization isn't something that's done yet, but it's something that theoretically would make it unnecessary to use helium to repressurize the tanks, because when you're sucking out all of that liquid to generate thrust and to burn it out the bottom, all of a sudden you've got a tank that's now empty and needs some fill in gas. Otherwise, it pulls a vacuum and the tank can actually implode from the vacuum created. Because these tanks are designed to handle pressure, not to handle vacuum. So
I never
that's,
knew that.
yeah.
You have to
So
backfill it with something
repressurization.
else that's not the gas. All right.
Yeah, yeah. So repressurization, a big deal. It's a capability that will eventually be uh, um, that will have to be an aspect of any launch vehicle, because presently the present state of the art is just using helium to keep to repressurize the tank as you use up the fuel.
Why not just use water? It's
Well,
liquid.
water would actually condense. If anything, water's it would freeze up and would would eventually just condense to the point of there would be uh, vacuum because the fuel is so cold. We were talking
Got
liquid
it.
oxygen, liquid hydrogen. So you need something with a much lower boiling or lower boiling temperature. So that means that the that you're not going to condense the helium. The tank, if you have a condensation that occurs, then all of a sudden your pressure spikes downward to a vacuum. So you don't want condensation to occur. So that's why helium is kept available there. So that means even though the liquid oxygen is um, is quite cold, it's actually the helium is still liquid inside the liquid oxygen, but can also evaporate more quickly than the liquid oxygen can evaporate, which gives it the ability to repressurize.
Plus, Benjamin, when you get to the moon, you can use that helium to entertain yourself while you're waiting for the resupply mission.
Correct.
Absolutely.
Yeah, double duty.
And actually recapturing that helium isn't a terrible idea. I mean, one could theoretically pump it back and use it and reuse that helium. And on the
Mm.
moon, you're going to see a lot of attempts to really try um, to keep the waste to a minimum, if at all possible.
No, that's fair. That's fair. I so I have a question about something that's kind of unrelated that we didn't get a chance to talk about last week. Oh, sorry, last episode. But I really want to know about your work with Electra Aero because you kind
Oh
of had
boy,
hinted
yeah.
about it last time. We didn't get a chance to talk about it. Yeah, we can
Electra's
come back to this, but
Oh yeah, no, Electra's pretty fascinating. Electra's getting ready to have a product reveal in a week. And it's pretty exciting stage for any small startup company to have a massive product reveal because it's their opportunity to show the world where they're going and what the product's going to look like. And so, what Electra Aero does is Electra Aero is an aerospace company, but it's completely terrestrial. They are looking to open up the ability to travel with an airplane to places you can't put an airport. Now, it's not a helicopter. It's not a VTOL. VTOLs are like the drones that you see, but with enough space to carry four people.
and VTOL
Then
is vertical takeoff and landing,
vertical
right?
takeoff and landing, exactly. And you have um, also helicopters, which we're all quite knowledgeable about, that have the ability to do vertical takeoff and landing to a certain degree. But a helicopter is really a rotating wing aircraft. It's not a VTOL. Helicopters actually have to pick up some speed to take off and take off in kind of a direction like this. But because you're spinning the wing, you're rotating this wing around at a very high rate of speed, you don't really need a lot of speed to, to lift because you've already generated lift. There are ways to get a helicopter to lift off straight up. But that generally involves creating an enormous amount of pitch on those wings and essentially creating a lift where this vertical speed of the helicopter combined with the pitch of the rotor creates upward lift in the upward direction. So you're
Mhm.
flying, it's like you're flying a plane upward that way. It takes a lot of energy and it's difficult for helicopters to do so, which makes helicopters extremely expensive to operate. Generally around 10 to 20 times more expensive to operate than fixed wing aircraft. So, how about if you could have a fixed wing aircraft that could land in the space of 150 feet? That is what Electra is doing. And they're doing it with an interesting technique. We use 8 electric motors across the wing to create a full laminar flow of air across the wing, even at zero speed. In other words, something along akin to a helicopter. The wings have an enormous amount of lift that's being generated, and the airplane could just be sitting on the runway. Now, that doesn't mean the airplane's going to take off. That just means a lot of lift is being generated. Now we start moving the airplane itself at around 20 knots, and that's just enough speed to take off. And when it takes off like a feather would take off from the ground if you puffed air under it. It's going around 20 miles an hour, and then all of this lift is being generated by the motors running at full power. And then that little extra movement forward essentially gives it kind of a gentle lift upward. And when we're talking about gentle lift upward, the angle of attack for this airplane is about 50 degrees. So I don't know if you've ever been on, on a very sudden takeoff in a small airplane, but typical angles of attack for liftoff are 9 degrees or 10 degrees. So now imagine 5 times that. In other words, instead of sitting facing forward, you're sitting facing up. Not too much different from taking off in a rocket. So, and actually more aggressive than most helicopter takeoffs. So
Wow.
for a standard helicopter takeoff, you're actually outperforming that with the ultra short capabilities of this fixed wing aircraft, and doing so at a ludicrously low speed. In other words, we're talking about the same speed that you would drive in a school zone
Yeah.
while kids are being let out. So
It's
you
wild.
and this is for landing as well as takeoff. So we're talking about the ability to have ultra short takeoffs and landings. Hybrid electric power makes this work. And the reason it does is the electric motors can have an enormous amount of peak energy, but not be overbuilt. The motors that we use right now are about the size of a melon, and there's 8 of them. Their peak power is hundreds of thousands of watts, equivalent to a couple of Teslas running full blast, if you want to use the Tesla electric motor analogy. But at a standard cruise, we're talking about 1/10 of that power to maintain a decent speed, around 120 miles an hour for a technology demonstrator, and quite a bit more for the actual product.
How long
So
And
can
so
it
the
fly?
demonstrator, sorry.
it's just a 2-seater, the
Yeah.
demonstrator. The actual product is a 9-seater.
How long can it maintain? I mean, how long can it carry a charge? How long can it fly for?
500 miles.
Dang!
Yeah. So and the reason is that the charge is only limited by the fuel you're carrying on board. So we're carrying 30 gallons of fuel, and that goes into a turbine, and that turbine is the source of energy for the entire system. So the turbine, a small battery, if you will, it's similar to like the Toyota Prius, where you have a small gasoline engine or a small turbine, in our case, generating electricity. And then that turbine and that generator keeps the battery topped off, and then the battery can provide whatever extra power is needed for those takeoffs and landings. And then for normal cruise, just cruise around at a very efficient rate.
It's so cool as well. And for folks who are listening at home, I highly recommend checking out the video of the demonstrators takeoff and landing, because I was watching it and I'm like, oh, okay, it's starting on the runway. And then half a second later, it's just you like straight up immediately in the air. And it almost looks unreal just how quickly it gets up and gets going. And the same thing with the landing. It like lands on the runway and you see it's got a mile of runway ahead of it and it basically stops like almost
Gently
right away.
too, which is great. It's
Yeah.
not like a jarring, screeching to a halt stop. It's not.
Yeah, I mean, there are, if you go on YouTube and you look up short takeoff and landing competitions, you'll be amazed at what they can do with these tiny 2-seater aircraft with enormous engines. And so there are certainly aficionados of this technology, and they that's a technology that's been around since the 50s. Um, and it's amazing the aircraft that exist. In fact, if you go to Alaska, you'll see ultra short takeoff and landing aircraft that were developed in the 50s, uh, running regular milk run routes right now. These are generally built on like old Lycoming 6-cylinder, 8-liter engines. They're powerful aircraft. They can can get into the tightest places and do what they need to do, landing on ice, landing on snow, landing on grass. And also in the African bush, apparently South Africa is another place you'll see a lot of aircraft like these. But these aircraft have not been redesigned or reintroduced since those 1950s, and those companies have long since gone out of business. Now imagine that you can get a turbine-powered, modern electric aircraft that costs pennies on the dollar to fly compared to these aircraft, and do it with 9 passengers and an extra 2,000 pounds of payload.
Very cool. Benjamin's just speechless. Nothing.
Actually, I can't even hear him.
He's shrugging silently. He might be muted, but he's shrugging silently and
I was muted. Oh my goodness. But yes, Kovi was right. My mind was blown, but I wasn't silent. I was muted.
Well, okay, that's amazing. I feel like between the New Glenn stuff and the Electra stuff, I mean, you've been involved in some incredible projects and continue to be. What's like the next thing that you're looking forward to in the coming few years, like the next big project?
Well, I'm a big fan of trash, and I love the
Yep.
ability to look at recycling in a way that makes some energy out of it. So this plasma waste recycling is an area that I've been interested in, and NASA has actually introduced a competition for exactly what can people do to do energy and waste recycling for lunar environments. So definitely for anyone who's interested in doing research in trash and waste management, the next step is to see what we can do in lunar infrastructure. So that's going to be pretty exciting. And I think the reason I look at that is there's a lot of green tech right now that I think we're going to see develop further as the world comes to grips with an ever changing environment. And
Mm-hmm.
I don't know if you guys had heard, but apparently the Everglades and the microbiome of the Everglades is what they say is leading to one of the largest sources of methane that is being emitted into the atmosphere. Now,
Wow.
what that means is that we have a toxic, not a toxic, but a potent greenhouse gas, 40 times more potent than carbon dioxide, being emitted from a space the size of Florida. And that it's possible that this enormous emission of methane is most likely the reason for what looks to be a spike, a dangerous spike in the greenhouse effect that we are starting to see. And as you know, with temperatures this year and the crazy weather phenomena, it is very strange to be living on this earth right now with these temperatures.
Yeah, wow. Definitely an important topic to be investigating and devoting our resources and time to. Wow.
Yeah. And it fixes the recycling problem, which apparently we have. The word on the street is you can't recycle anything. But with plasma, you can. You can. You're not really recycling it, but you're burning it and turning it back into its constituent atoms, and then from that, using it to generate fuel or rocket fuel.
Perfect. We've come full circle or full
You've
orbit,
gone
if
full
you will.
circle.
Well
Absolutely.
done.
Man.
All
Benjamin,
right.
did you have any other questions? I feel
No,
like
this is we've eaten up a lot of time covering a lot of ground. Yes, I have 1,000 more questions. I can fill several more episodes, but
Well, let's take your top one. You got
fantastic.
it. You got it. I'm here. I'm happy to answer a few.
I'm not good under
Just put you on
pressure.
the spot, man.
Um, I was gonna go back to Blue Origin question.
Let's do it.
I've been Blue Origin is no plan as far as the Artemis program goes. Blue Origin is going to be a big participant as far as being a heavy lifter, bringing the Blue Moon lander thing that they have there, but they're not going to be able to bring people. That's going to be going through another carrier. Does Blue Origin have any plans of creating a people transport?
Well, as far as I know, there's still plans for Mark 1 and Mark 2 lunar lander. So
Mm-hmm.
Mark 2 will be the people one. And that's a great question. So Mark 1 will be the demonstration unmanned lander. But yes, there is a lander going to the moon. The people lander will also have, as a fun extra benefit, a little rover attached to the top of it with a crane. So when it lands, it'll land and then deploy its legs, and then a little crane will turn around and pick the rover right off the top of the lander and drop it on the ground.
Now that's a Lego set.
Yes, that would keep me entertained for hours and hours along with the kid. I mean, at that point, everyone's going to be wanting just to figure out how it's all going to work. So that would be a
Absolutely.
great Lego set, but you also need like the vast lunar landscape. So I would hope that it would ship with like a big welcome mat that you would roll out that would look like the surface of the moon.
That'd be cool.
It used to
And
be a big
just to,
lunar base plate that came with space sets from early Lego sets, but they don't offer it anymore, and it makes me sad.
yeah.
But
Wish there's like
anybody
a,
who has one of those, go on eBay. It's a collector's item.
I wonder if there's a carpet that you can buy that's just the surface of the moon, like an accurate depiction of the
Gotta be.
surface of the moon.
Gotta be.
I
Let's
would
not
put that in my
keep giving
list.
away the beautiful ideas on the air.
Should copyright it now. Space carpet.
All right. That's all for me. How about you, Kavi? You good?
I feel like it would be a great time to pause and prepare for our next episode with Dimos, because there will definitely be a third one.
Oh yeah. Oh yeah.
Well, I mean, we could always have a retrospective after the launch, or we could just
Deal.
talk about Electra and what exciting stuff they're doing post product reveal.
Yes. No, I'm glad that we got a
There you
chance to
go.
talk about it today, and it would be great to speak about both of those after they've had their big moment in the sun. But yeah, wow, thank you as always for being incredibly generous with your time.
Thank you.
This has been fun. It's been good.
Been great.
All right. Well, any opportunity I get to play with my models is a great opportunity.
I'm
Here we
happy
go.
we
We
could
get to
help.
do it for the benefit of Earth.
There you go.
Yes,
Play with your toys
absolutely.
for the benefit of Earth. You heard it here, people.
Love it. And Dimos, remind us again where folks can find you if they're so inclined online.
Well, you can find me on LinkedIn, and also arivnamedia.com or .org is another place that you can contact me. And my LinkedIn account, my LinkedIn page shows essentially right now as on Electra. So you'll see Electra associated with my name at this point.
Excellent.
Very cool.
How about you, Kavi? Where can people find you?
Folks can find me at Fun Fact Science on all of the social medias. What about yourself, Benjamin?
You can find me at Science Actually at all the social medias. And you can also find this show wherever you're listening to it right now, hopefully. And you can also watch us on TikTok, watch us on YouTube, and get a good look at Dimos's model Blue Origin rocket, which is so big it does not fit in the screen.
Even the first stage doesn't fit. Yeah.
Doesn't fit.
Here we go. One more shot of the second
There,
stage.
just
Nice.
the second stage. There you go. All right,
Too
gang.
bad it's not a beer can.
Innovation.
Fantastic. All right. We'll see you all next time on Science Actually Presents the Nerd and the Scientist.
See y'all.
Wonderful.
Thank you.
Thanks, Black Shirt Club.